So I want you to look, we'll talk about our target in just a second. I want you to look right there. Let's go ahead and, this is for lesson 10 today, but we're going to stop for just a second and look right here. This is our kind of warm-up review. We definitely need something. I don't know about you. I definitely need something to get me focused on math right now. Okay. So let's look at the first one. Everybody, what's the answer to the first one?
4.
Definitely 4. Okay. There it is. There it is. All right. What about the second one?
80.
Okay. So we did that one together too. That's 80. The third one and the fourth one, let's not yell out. The third one, okay, look at that. Mason, what would that be?
600.
Okay. And a quick way to do that, can you describe a quick way to figure that out?
Think of 3 times 2.
Okay. That's exactly what we would do. And then add the what?
2 zeros.
Okay. You could actually think of it, if I took that and wrote it 2 times 300. Remember that little trick of boxing in those 2 digits and think of that. 2 times 3 is 6. Let me have your eyes up here. They are not in our desk right now. Okay. 2 times 3 is 6. And then add 2 zeros. And so if it helps you to box in those 2 digits on a problem like that, do it. Anything like that that helps you, you know. Okay, now I want is it a question about this one?
No.
Okay. This one I want everybody to take a second and think about. Okay. Okay. I want everybody to try and come up with that answer. And if you have to, picture it like this. Picture it turned this way. And think about what we did yesterday. Yesterday's standard algorithm might be helping a lot of you do this kind of mental math. Okay? I want everybody to have an answer in mind. What would that be? Brandon, what do you think?
684.
684? Did I hear you right? Okay. Anybody agree, disagree with Brandon, or maybe you have a different answer? A lot of agreement. Yes, if we took our standard algorithm to check you, okay, 2 times 2 is 4, 2 times 4 is 8, and 2 times 3 is 6. Okay, good job. All right. Now, at first glance, you might think, how did somebody do that in their mind without writing it down? It just takes practice. It just takes time, but you guys are getting a lot stronger and a lot better, maybe more than you realize, with your multiplication. Okay, we are going to continue on with our standard algorithm today. I do want to do this review since we're still reviewing. I thought this was a good one to bring in. So since we need a little bit of work area, let's go ahead and get out our boards and our markers and have that ready in front of us. Go ahead and get those things out. We do not need our place value chart, just the whiteboard and the markers. What? Okay. So on your whiteboard, I want you to try your best. Now this is going to take a little space. So you might need to start way over on one end. You might even need several rows to do this, but I want you to try and write this number in words. No numbers, just words. So it's not unit form, it's word form. 4 million. I'm going to say it once, and then I'm going to have you say it with me. Okay, let's get our focus up here, not on our markers right now. 4,567,200 231. It is almost like each of these is a separate number. And if you will read them that way, you're going to read it correctly. Read each of those pieces like they're their own separate number. And when you get to the comma, you're going to add, of course, the word million and the word thousand. But that's also going to help you write it correctly, because you're going to write what we say. So let's say it together. 4,567,231. Okay? I know this is 4. I know this is 567. I know this is 231. I say it exactly like that with the million and the thousand words in between. Okay? So give this a try with your words. I want you to look at home. Just okay. Try to write that number in words. 4,567,231. Let me give you a minute to do that. Write the word 4. Write the word million. This is all together. 567,000. Okay? So the word thousand doesn't come until you've written that whole number. Okay? Those chunks have to kind of stay together. And it's okay if things aren't spelled 100% correct. Okay. 567. No numbers. No numbers at all. Okay. And just sound it out. I'm not worried about if it's spelled correctly. Good. Put that down. Get your marker going. Put it down on the floor right now, okay? We're writing that as words. All right, so let me catch up to you. 4,000,000. 567,000. Sorry, I'm having to squish this in here. 200. And if you wrote 231, 231, either one of those is fine. Some people throw that and in there. 231. Okay? A lot of words for a very big number. Okie doke. Now, let's move on to this. We've got the area and we've got the perimeter. It says find the area and find the perimeter. Our area is going to be the length times the width. And it's just been a few days since we've had this. And now, do we know how to take a 2-digit number times a 1-digit number?
Yes.
Yes, we do. Okay. So to find that area, I'm going to multiply my length times my width. Okay. All right, let's just find the area first.
Do we erase?
You can, or you can switch it in there at the bottom. Let's write that problem like this. Let's get used to doing this. Okay. Try to think about what we did yesterday. How would we solve this? Charlie, what would we do first?
We would do 15 times 8, and then we would do 5 times 8, which is 40.
Yeah, 8 times 5, 40. What would I write first?
The 0.
The 0, which is in the ones place. Please stop. And I would what?
Then you would put the 4 up by the 1.
Yeah, I would carry that 4. Good. Okay. What comes next? I hear another voice. Go ahead.
8 times 1 equals 8. Then you add the 4 to it, and our will equal 12.
Okay. So that ones place goes to the ones place, then the ones place goes to the tens place. So 8 times 1 is 8, plus 4 more is 12. I can't put the 2 and carry the 1. There's nowhere to carry it to, so I'm going to write that whole 12 right here. And since this is area, it's not just 120, it's 120.
Square centimeters. No.
It's meters this time.
Square.
Square meters. And this is one way to write it, just to abbreviate it. There's actually a few ways to write it. Okay. All right. What would we do to find the perimeter? What's the simple, what would we do, Mason?
15 times 2 and 8 times 2.
15 times 2, 8 times 2, and then those two numbers, we'd what?
Equal them.
Well, we'd add them, wouldn't we? We would add them together because we need to know this and this and this and this all together. You could add them all, or you could multiply this by 2 since there's 2 of them, and this by 2 since there's 2 of them, and then add those together. All right, find the perimeter right quick. Give that a try. What would we get if we found the perimeter? Put all of these things together. What do you think we would come up with? Now, what'd you get? 46 what? What unit are they using? Do you know what the M stands for? It's meters. And you remember when they dropped the mic a minute ago on the science video? Okay. And they said they're going to drop it from 1 meter, and then 2 meters, and then 3 meters when it finally broke. Okay, that 1 meter length, it's about from the floor to a doorknob. It's about the length of a baseball bat. That's about a meter. So that's the kind of measurement they're talking about. So our perimeter would be what? Say your number one more time. Yeah, he got 46. How many of you got 46 for the perimeter? Yeah, I saw that on a lot of your boards. Okay, you can add 15 twice. 15 and 15, 30. That's pretty automatic. What helps us know our 15s?
Our fives.
No, I guess, well, it can. It definitely can. I hadn't thought of that. That's a great strategy. But there's something in the real world. There's one hanging in our classroom that helps you with 15s. What am I talking about?
The flag.
I'll be honest, y'all don't use it very much. I don't know how flag's going to help you with 15s.
That's how I do it.
Yeah, you might have done it different, but I'm just asking this question. Because we're going to talk a lot more about this later in the year, but I thought, why not throw this out there right now? What?
Brownie points? True.
Okay, but let's use our reasoning. If I say it's hanging in the classroom, it's probably going to have some kind of numbering something on it. If it helps us with 15, definitely the clock. Yeah. Unfortunately, a lot of you don't know that clock over there, but that clock helps you with a lot of things. Okay, that clock. A lot of people divided it up into 15-minute chunks. Okay.
Yeah, I see about 10, 15.
From up here, and I'm talking minutes, because there's 60 minutes in an hour, right? For those hands to go all the way around, that's 60. Okay? Well, from here to here, that's 15. From here to here, that's 15. From here to here, that's 15. And from here to here, that's 15. Okay? If I say, well, it's half past the hour, that's 30. 2 15s is 30. 3 15s is 45. All of the 15s, all 4 of them, is 60. And so if you know your clock, that helps you with your 15s, okay? Just a little bit of extra information today. 15 times 2. 2 times 5 is 10. 2 times 1 is 2, plus 1 more is 3. That is one way you could have figured that out. 8 times 2 we already know is 16. And so that equals 46. That was one way to do that. 46 meters. Okay? All right, go ahead and clear off your board. Not going to work. Now I'm going to change those directions right there. Or am I? Yeah, I am for you. This is what we'll do. I thought yesterday or last night, I was like, am I going to have them do partial product again? I don't know if I want to. I'm not sure. I think I'm going to do it on the board and show it to you, but I want you, since we are in the frame of mind of doing their standard algorithm, let's keep going with that, okay? So we're going to talk through this. A few of you were not here yesterday. Make sure you are really tuned in because we've already done this one day, and this is going to be a practice day for these kinds of problems, okay? So I need you to grab onto this if this is not, if you were not here yesterday. Make sure you're not coloring it on. All right, so how are we going to write this on our board? I'm going to switch us over to our other board where we have a little more space. Okay, we're going to go ahead and get this on our board. Let me write it for you since I took it away. We've got 2,374 times 5. Okay, now I want you to go ahead and, well, I tell you what, let's work through this one together. We'll just do one together. I know that some of you are ready to do this on your own. Let's work through this one together. So make sure you are right here with me. You've already got this written because it's that fast. Okay? Guys, you've got to stay with us when we're doing these things. Okay, just like that, just go back and see it. Okay. All right. So here we go. We're going to walk through this, and I want you to stay with us and write these same steps. What would we do first?
You will.
Okay, what would we do first? Yes.
You're gonna do 5 times 4.
We're going to start here. We're always going to start right here with this number. Even if there are other digits here, we're always going to start with the ones place. And the ones place is going to multiply with the ones place. So Charlotte's right. 5 times 4. Charlotte, what is 5 times 4?
20.
20. So what am I going to write here? 20?
No.
Not today, I'm not. I did the other day. But now we're learning standard algorithm, which is different. What am I going to write?
You're gonna put the 0.
I'm going to put the 0. I'm going to put what was in the ones place from that answer. And what am I going to do with the 2?
Then you're gonna carry it to the 7.
Exactly. We're going to carry it right over here to the 7. Okay, so make sure you've done that on your board too. Okay, we're ready for the next step. What's our next step going to be? Yes.
Multiply 5 times 70.
Okay, not 70.
Plus 7.
Okay, with standard algorithm, we're just going to look at these as single digits instead of, it is a 70. We know that because it's in the tens place, and you're right, but all we have to think is 5 times 7. What is 5 times 7?
35.
35. But Martin, what about this thing? What am I going to do?
You're gonna add it to 35, and it's gonna be 37.
Okay, time out. I need y'all to hear this. Because just like I help them with things I see in here, I help you with things I see next door over here. Yesterday we were trying our best with this, and every now and then people would get mixed up with what to do with this little number, or they would forget about it. Okay, listen. This is multiplying, but these we add. Okay? 5 times 7 is 35, plus 2 more, 36, 37. So I'm going to write the 7 and carry the what?
3.
The 3. Why am I carrying that tens digit number over? Why am I doing that, Mason?
Because it won't fit.
It won't fit. You have to imagine if we had the place value chart, that would be 3 bundles of 10 dots that we're drawing an arrow and moving over to the next place value because it won't fit. Okay, what's the next step? Let's keep going. Faith, what's the next step?
Multiply 5 and 3.
Multiply the 5 times the 3. See, we've gone to the ones place, we've gone to the tens place, now we're ready for the hundreds place. Okay, what is 5 times 3?
15.
Good, 15 plus 3 more. So 15, 16, 17, 18. So I've got 18. How am I going to write that 18? Alexandra, what am I going to write?
8 at the bottom.
Say it one more time.
8 at the
8 at
bottom.
the bottom.
And
And carry the 1. Can y'all see the 18? It's just stretched out. Here's the 1 and here's the 8.
Yeah.
You know, it's just like somebody went, okay. Oh, the ones place will fit, but the tens place, we got to move over. We got to move it to the next place. Okay. Okay, what's our last step here? Come on, Bailey, what do we do? 5 times 2. We've made it out to the thousands place. 5 times 2 is 10 plus the 1 more is 11. Now, do I have another place to carry that 1 to? I don't. So you know what I do this time? I know you know.
You just put 11.
I put the whole thing right here. Okay? 5 times 2 is 10 plus 1 more is 11. I don't just put a 1 and oh, watch. Watch what would happen if I put my 1. If I put my 1 and tried to carry and there's nothing there, it's just going to fall straight down anyway, isn't it? Because there's nothing there. It's nothing for it to sit up on, you know?
You left the comma out.
No, I just wasn't ready for it, but now I'm ready for it. And thanks for the reminder. Okay, so there's our answer. So it's really just a slowly take step by step. Okay, you're multiplying here, then here, and then here. Okay, the carrying gets a little tricky, and it's not hard. It's just remembering to put it up there, remembering to add it in. Okay. All right. Let's just keep going. I think we're on a good roll here. Let's try this one. I know you can't see it yet. Let me write it for you. I'm just moving to this board where we've got more room. Okay, you can clear off your board, and we're going to do another one. I'm going to let us do it a little bit more on our own at first, and then we'll work it out so you can see the steps. 3,817 times 6. Okay. Let me give you a minute to get started. Why do you think that it's taken us a little longer to do this one? Because as I've walked around, I've seen a lot of you sitting there staring at your board. I like these boards. I think you do too. They're great. Great boards. They're becoming our friends because they're traveling with us every day in our backpack. However, no matter how long you stare at it, it's not going to magically appear. The answer is not going to magically appear for you. So, why do you think we're doing that, Charlotte?
Because it's 6 instead of 3.
Yeah. When I get above 5 here, it takes us a lot longer to get that answer sometimes. And I get that. We are not as comfortable with our 6s, 7s, 8s, and 9s. It's that group of, we get to 10, we're good. 11, we're flying through the 11s. 12, yeah, that slows us down a little bit too, because we do need to know her 12. Okay, that's coming soon. All right, so this is one more reason we need to know our math facts. Okay, so if this is slowing you down, be practicing at home. That's important. All right, let's go through this one. Some of you had it. I mean, you were like, and then one little thing somewhere in the middle. This is what frustrates people a lot of times. We have these big problems. It's just like adding and subtracting, where one little bitty thing in the middle of the problem somewhere got you. Okay. So 6 times 7 is what, everybody?
42.
42. Okay. Had that silent pause there. Got me worried. 42. So we're going to put the ones place and carry the tens place because it won't fit. It's got to go to the next place over. Okay. 6 times 1 is what, everybody? 6. Plus 4 more is 10. I put my 0 from the ones place and carry the tens place over. And that's supposed to be a 1, even though it's a little weird looking. Okay. 6 times 8 is what?
48.
48. Plus 1 more is 49. I put my ones place, which is a 9, and carry the tens place over, which is a 4. 6 times 3 is what?
18.
By the end of the year, we're not going to have this pause here. 6 times 8 is what?
18.
Here we go. Plus 4 more.
24.
Okay.
I mean 22.
All right, we got 18, 19, 20, 21, 22. Here's our answer. Okay. And like I said, some of you were very, very close. There was just one little spot in there a few times where we needed to fix something. Yeah.
I needed to just fix my 22 because I had 21.
Yeah, it's like you just counted up 3 instead of 4. Okay, thanks for sharing that because when we hear what someone else's mistakes are, that helps us. Okay, Martin says he just counted accidentally up 3 instead of 4. Anybody else notice something that you did? Yeah.
I didn't multiply 6 times 8 right.
Okay, so you caught on to multiplication facts. Same over here. Yeah, same. Okay. We just got to get used to them. We got to, where it's like blinking, 6 times 3, 18. It's just, them. Okay. You'll get there, but you're not going to get there if you don't practice them. It does not happen by itself. Okay. All right. Now we practice them some at school, but I can't do all the practicing at school that you need. You do need more than that. Okie doke. Let's look at this. I'm going to go back to our regular chart. Okay, now sometimes our multiplication with multi-digits is going to show itself this way. It did yesterday a little bit. We're going to see it a little bit today as well. So who can read that for us nice and loud? Big boys, nice and loud. Ishmael, go ahead.
There are 5,280 feet in a mile. If Brian ran 4 miles, how many feet did he run?
Okay, good. I don't have my small rulers out yet. We haven't needed them yet. This is a ruler. Let's see, on this side, this is, okay, listen for just a second. Right here where my hand is, from here to here, that is 1 foot. It's 12 inches. If you look at the squares on the floor, they are 1 foot long. They're not talking about the feet that you actually have at the end of your legs, because everybody's feet are different sizes, exactly. But a foot that we measure with is 12 inches, and it's as long as one of these squares on the floor, which is this long right here. Okay? There are 5,280 of those in 1 mile. Okay? That's just a good number to learn. A lot of people just know that. They've memorized it. They know that there are 5,280 feet in a mile. Okay. So if he ran 4 miles, How many feet? Here's our question. How many feet did he run? They don't want to know how many miles. They want to know how many feet. How would we figure this out? Okay, if I ask you to draw something for this, do you have to draw Brian running?
Yeah.
No. You know, wind in his hair? No, you don't have to draw that. That's not what they mean by draw. Draw something to help you figure this out. That's not going to do it. You're not going to magically know the number.
Times 4.
What now?
5,280 times 4.
How could we show that in a picture?
Because it says Ryan. If Ryan ran 4 miles, how many feet did he run?
No, and I agree with you. And if you can pull that from words and you know what to do from words, that's great. But some people need to see something. So what could we draw? Say it one more time. I need my big ears today. Place value chart. You could. I don't know if that would help you much. You could do the multiplication on the place value chart if you wanted to. But even before that, so that you know you've got to multiply, what could we draw? What could we draw? Yeah. You could. You would need an awfully long one to get to all of the. You'd be in the thousands. Okay. What if I just did this? Would that help anybody? Could it?
Could. A little bit. No.
What could I put beside each of those? You know
The number 5,000.
he ran 4 miles. Let's say this is like a track and he's running around that track and each of those is a mile and each of those is how many feet?
5,280.
Every one of these is 5,280. Oh, okay, so he ran this, and he ran this, and he ran this, and he ran this. How many feet did he run altogether? Now, last year you learned if you're adding the same number repeatedly, what's an easier way to do that? Multiply. Just what Mason said a minute ago. This is multiplication. This is 5,280 4 times. Listen to that language. 5,280 4 times. Okay. Because there's going to come a time where we're working on word problems, and I may say, I'm going to have you draw something this time. Okay. Was that hard to draw right there? No, but what that let me know is that I am putting all of that together. What's an easy way to do that? Well, I know I can do this. Okay, so let's do that on our board right now. 5,280. There's a 0.
Oh my God! I didn't even see that. Oh no!
Don't let the 0. Look, I have a fear of spiders. You all saw the demonstration of that this morning. You know, cheers, chills, and sweat, and a lot of real fear. I know that I'm a lot bigger than that thing, and I know I can smush it. And if I was where I could have, I might have. However, I knew I could get some help too, so I did. Okay. So don't let a 0 scare you off. let's check this. 5,280 times 4. A very quick check here. 4 times 0 is
0.
0. 4 times 8 is 32. 32. We're going to put that 2. We're going to carry the 3. 4 times 2? 8 plus 3 more. 9, 10, 11. 4 times 5? 20. Plus 1 more? 21. And there's nowhere to, to carry to, so we're going to write that whole 21 right there. 21 feet is our final answer if we're adding that label. 21,120 feet. Okay? Anybody get that?
Yes.
Good. We will in just a second. All right, we are ready to move into our problem set, and it is just several problems to practice. Okay? So that is what we will do when we come back from our break, is just continue to practice this type of multiplication with standard algorithm.